In 1994, Andrew Wiles solved a mathematical enigma that had baffled scholars for 357 years. The journey began in the 17th century with Pierre de Fermat, a French mathematician who proposed a deceptively simple problem. Fermat claimed that no three positive integers AAA, BBB, and CCC can satisfy the equation n plus bn equals cna caret n plus b caret n equals c caret nan plus bn equals cn for any integer value of n greater than 2. This statement, known as Fermat's last theorem, seemed plausible, yet Fermat never provided the proof. Instead, he scribbled in the margin of his copy of Arithmetica that he had a truly marvelous proof, but that the margin was too small to contain it. Thus began centuries of mathematical intrigue. For over 3 centuries, Fermat's last theorem was a mathematical curiosity that resisted solution. Numerous attempts were made, with many great minds like Leonhard Euler proving specific cases such as n equals 3, n equals 3, n equals 3, but a general proof eluded everyone. The problem tantalized mathematicians because it was easy to understand but seemingly impossible to solve. Andrew Wiles encountered Fermat's last theorem in 1963, as a 10-year-old browsing the library in Cambridge, England. His fascination with the problem was immediate and lifelong. As Wiles described it, here was a problem that I, a 10-year-old, could understand, and I knew from that moment that I would never let it go. I had to solve it. Wiles' determination stood out. Despite centuries of failure by the brightest mathematical minds, Wiles pursued the solution with unwavering dedication. His path to the solution, however, was not straightforward. In the 1970s, while a graduate student at the University of Cambridge, his supervisor John Coates recommended that he study elliptic curves, a decision that would later prove crucial. The 1950s saw Japanese mathematicians Yutaka Taniyama and Guro Shimura propose a connection between elliptic curves and modular forms, known as the Taniyama-Shimura conjecture. This conjecture linked two seemingly unrelated areas of mathematics, and in 1986, Ken Ribot demonstrated that if the Taniyama-Shimura conjecture were true, it would imply Fermat's last theorem was also true. This meant that proving the Taniyama-Shimura conjecture would simultaneously prove Fermat's last theorem. This revelation electrified Wiles, who realized that his childhood dream was now within reach. By the late 1980s, Wiles was a professor at Princeton University. He decided to focus on proving the Taniyama-Shimura conjecture. For 7 years, he worked in complete secrecy, confined to his attic, telling only his wife of his quest. His secrecy was partly to avoid distraction and partly to prevent a rival from beating him to the solution. Wiles initially worked on proving the conjecture for a specific class of elliptic curves. His strategy was methodical, like toppling the first domino in a long line, ensuring that each subsequent domino would also fall. Yet, after 5 years, he hit a roadblock and emerged from seclusion, seeking fresh ideas. In 1991, a conference in Boston provided him with a crucial breakthrough. There, he learned about Matthias Flach's work on elliptic equations, building on the Kolyvagin method, which offered new techniques for analyzing these curves. Even with this new approach, progress was slow. In 1993, realizing he needed assistance, Wiles confided in his colleague Nick Katz. Together, they secretly worked on verifying Wiles' calculations under the guise of a graduate course. Katz confirmed that the Kolyvagin-Flach method was effective, but there was still a missing piece. In May 1993, Wiles completed what he believed was a proof and announced his findings at a conference in Cambridge. The initial reception was euphoric, but the rigorous peer review process revealed a flaw. The error was found in the part of the proof involving the Kolyvagin-Flach method. Despite this setback, Wiles remained optimistic, believing the issue could be resolved with additional work. Months passed without a solution. Then, in September 1994, a breakthrough occurred. Wiles realized that by combining the insights from the Kolyvagin-Flach method with another mathematical approach he had studied, he could patch the gap in his proof. This eureka moment came after nearly a decade of intense effort. In May 1995, Wiles' 129-page proof was finally published in the Annals of Mathematics, and Fermat's last theorem was no longer a mystery. Wiles reflected on the journey, expressing a mix of loss and freedom. Having solved this problem, there's certainly a sense of loss, but at the same time, there is this tremendous sense of freedom. That particular odyssey is now over. My mind is at rest. Wiles' achievement was celebrated globally, and he received numerous accolades, including the Abel Prize, often regarded as the Nobel Prize of Mathematics. His journey from a fascinated 10-year-old to the solver of one of history's most famous mathematical problems is a testament to persistence, creativity, and the relentless pursuit of knowledge. For those inspired by Wiles' story and interested in mathematics, resources like Brilliant.org offer an engaging way to develop problem-solving skills. With courses designed to make complex topics intuitive, anyone can start their journey into the world of mathematics and perhaps solve the next great mystery.